If you remember the last class, 1D arrays, I was asking you uh, why array index starts from 0. Anyone has an idea? Why array index starts from 0? Anyone? Remember I asked the question, why index starts from 0? If we don't know type, don't know at least. Let's not waste much time here. Continuous memory, yeah, that is one reason, but why is it happening? What you should understand here is, okay, that can anyone say what is an array? Definition of an array. Good. We did discuss few definitions. Collection of homogeneous elements stored in a continuous number allocation. Good. Any other? Collection of elements, all those things. But I'm gonna give you a new definition. What I'm telling is an array is a pointer. How many of you agree with me? An array is a pointer. Vedha says yes. Others? Oh, a lot of people are agreeing. Why do you agree? Is the question. On what basis you are agreeing to me? So look at here to understand why I was making that statement. An array is a pointer. Let's see that. You have learned. I don't know why, but today we are facing a lot of issues. Issues with pen, issues with internet, issues with power. Let's hope there are no more issues. Yeah, it's working now. Fine. Go on again. Just a moment, guys. Just a minute. Give me a minute, guys. Yes, Amaya. Chalo. Let's take an array. let's take an array. If I make an integer array, this looks like this. ARR of some 5. So when I make an array looks like this. Array looks like this with address 100, 104, 108, 112, and 160. Okay, this is index 0, 1, 2, 3, 4. So this is basically array of 0, array of 1, array of 2, array of 3, array of 4. The values inside them are 1, 2, 3, 4, and 5. Is this array clear? Yes. So this is what we assume. But what happens behind this? There is also a variable created like ARR, same name as array name, which stores the base address 100. The concept we are going to learn is called as pointer arithmetic. Listen here. What is pointer arithmetic? Pointer arithmetic is PTR plus I. Here the PTR is ARR. Remember, because it is storing the base address. So this becomes an pointer. Okay. What is ARR plus ARR plus I? It's not just PTR plus I into size of the data type as well. Integer 4 bytes, float 4 bytes, double 8 bytes, character 1 byte, it's like that. Okay. Now listen. So ARR plus I. ARR means here it is 100. Now listen here. When I write 100 plus I, that is 0, initial address 0 into 4 gives me 100. Now how am I getting this? When I write ARR plus I, if I is 0, gives me 100 plus 0 into 4, that is. Similarly, let's say this is 0, then we have ARR plus 1, which gives 100 plus 1 into 4, that is equals to 1. Similarly, ARR plus 2, which gives me 100 plus 2 into 4, that is 108. Similarly, ARR plus 3, which are equal to 100 plus 3 into 4, 112. And ARR plus 4, which gives me 100 plus 4 into 4, which is 160. This ARR plus 0 is same as ampersand ARR of 0. Is that the address of ARR of 0 and ARR plus 0 same? And observe this here as well. Address of ARR of 1 isn't same as ARR plus 1, and so on. This goes like this. Is this point clear? Is this point clear? What you see on the screen. Now imagine in place of this 0, there is 1. Then what will be the value here? This will be 104. If it is 104, will I point to first value or second value in the array? I'll point to the second value in the array. Then where is first value gone? It's gone. You can't access. That is the reason. Okay. So that is the reason we start index with 0. This concept is called as pointer arithmetic. Pointer arithmetic. So remember this. In this, you have to remember one thing. That is ARR plus I is same as address of ARR of I. How about value then? What if I want ARR of I, then I should get value at ARR plus I. Remember these two lines. And also remember ARR, that is 100, is equals to 100, and address of ARR of 0 also equals to 100, and ARR plus 0 also equal to 100. And one more thing, address of ARR is also equal to 100. Am I clear here, everyone? Is this clear, everyone? Chalo. Do you want to note down this thing? Please note down or take a screenshot of it. Please do that. Everyone, are we done with this? Any doubt? Everyone, any doubt? No doubts. Chalo. So this is about pointer arithmetic. So what I am telling is this array I am telling you. Let me show you using a program here. So what I will do is I'll just create an array. Okay. In this array, let me keep some values. What values am? Oh, let not keep some values. Let's keep. Let's take n. Let's take April runtime only. Ampersand n. Then I create n. Now observe here. I'll take for int I is equals to 0, I less than n, I plus. In here, usually I write scanf ampersand array of I. Instead of array of I, what am I supposed to use here? Anyone tell me? This is what usually I write. But what should I write here instead of that? We just discussed. What should I write there? I will write ARR plus I. Similarly, if I want to print, how do I write if I want to print? Same loop, no change. I'll write printf percentile d star ARR plus I. This is same as ARR of I. Observe here, my loop, my array runs very well. Observe here, I'll give a run. I'll give 5 inputs 1, 2, 3, 4, 5. works. So even if I write like this has to be converted to this and then it gets executed. Are we clear here? Everyone, are we clear? So did you take picture of this one as well? Please take this picture or note it down. Once you're done, put done, sir. Good. Are we clear, everyone? ఒక చిన్న కాన్సెప్ట్ ఉంది that is dynamic memory allocation. Let's quickly learn the dynamic memory allocation and then move with the next concepts. So what is dynamic memory allocation, anyone? What's DMA? Quickly, guys. So again, I'm telling you, I have a maximum charge of 30 minutes. Okay, so let us finish as much concept as possible. I have to teach you MLOC, CLOC, RealLoc free. Okay, then I'll give you assignment you can do. So we might not go till 1 p.m. today. So let's try to cover as much as possible. If it remains, we'll see in the next class. Chalo. So MLOC allocates memory. So if you observe this last time code, we were using static allocation where we write int array of 5. That means 5 blocks are created and allocated. Okay, but that is not how dynamic memory allocation works. Okay, dynamic memory allocation works uh, where the user allocates the memory, the required memory. And if you see dynamic memory allocation, the advantage of DMA is you can resize your array size. You can change, increase or decrease array size, but usually you declare statically an array size cannot be changed. Okay, it's fixed. That's it. Once you create, that's it. You cannot increase or decrease the size. There's a major advantage we have in DMA. Now, what happens in a DMA? In a DMA, we have again 4 functions. Okay. So we have DMA, meaning dynamic memory allocation. Okay. In the dynamic memory allocation, so what we have? We have malloc. We have we allocate memory dynamically. Allocate memory dynamically. Okay, usually at runtime. At runtime. Okay, the functions used are malloc, cloc, third one realloc, the last one is free. This free we have seen earlier, the morning session, first half of session. Okay, all these functions are present in stdlib.h header file. Okay, so if you want to use this, you have to include that stdlib. Let's use malloc. First one is malloc. What's malloc? What's malloc, guys? Allocates one single large block of memory. Allocates one single large block of memory. Okay, then default value when malloc used is 0, returns null if allocation doesn't happen. Are we clear? And also has one argument. Okay, let's see how syntax of this malloc is. Syntax of malloc goes like this: pointer variable is equals to cast type pointer usually, and malloc n number of values, number of blocks into size of the cast type. You can write cast type as well here. This is the syntax. Let's allocate a point. First of all, I'll make star ARR. What is this? It's just a pointer. It is no more an array. It's just a pointer. Okay. Then what we will do? I'll give ARR is equal to start giving allocation. malloc. How many values I want? I want n values. N into size of integer data type, because n values I'm giving of integer. So you don't have n variable. Let's declare that as well. Let's create n, then scanf read the values percentile d ampersand n. Okay. Now here what will come in the array? Now remember, malloc returns a void pointer. malloc returns a void pointer if memory is allocated. So what is void pointer? We will just learn it. You can convert it to any type you want. So what happens is malloc will give allocation for all kind of pointers. Just a minute, guys. Yes, guys. So malloc allocates memory. Sorry, where are we? malloc. Yeah, malloc returns a void pointer. Okay, so void pointer, why it returns? malloc allocates memory for all kind of data types. Maybe integer, might be character, might be float, might be double, any data type. So it cannot give a memory for one specific data type. So it gives in terms of void memory that needs to be converted to the required type. Here my ARR is an int pointer. I'll just write int star, meaning int pointer. So this is how I create an array using a pointer. In other words, a dynamically allocated array, memory allocated array. Is this clear? Everyone. Now, how do I run this? Same way you work with an array. I is equals to 0, I less than n, I plus plus. Okay, then give printf, sorry, scanf first. Let's take a scanf percentile d. Okay, then you write ampersand and ampersand. Just write ARR plus I. And when you want to read input, print in output, let's say I less than n, I plus plus. Just give printf percentile d, comma star ARR plus I. This is how it works. Is this clear? This is clear, everyone? Chalo. This is how we work with MLOC. Now, how about CLOC? Now, MLOC and CLOC both are almost the same, but the difference is, but the difference here is, but the difference here is, but the difference here is, this is continuous allocation, meaning it allocates multiple blocks. Okay, it allocates multiple blocks of memory. Default value 0. It also doesn't allocation doesn't happen. Has basically two arguments. Has basically two arguments. Okay, and also returns void if memory doesn't get allocated. And the default value is, sorry, here it is garbage value, and here it is 0. That's the difference. And here it is CLOC, and he can observe two arguments, so n comma size of that particular cache type. Sir, what you are telling? We are getting confused between MLOC and CLOC. I will give you an understanding. Let's say I have a continuous blocks of memory. So now MLOC ఏం చేస్తుంది? Let's say ఇక్కడ 5 అనే వాల్యూ ఉంది, ఇక్కడ 10 ఉంది, ఇక్కడ 25 ఉంది. ఇది ఉంటుంది. 5 కంటిన్యూస్ బ్లాక్స్ ఇక్కడ ఉన్నాయి. మెమరీ ఇక్కడ ఖాళీ ఉంది. ఈ మెమరీ ఇస్తుంది. ఓకే, దిస్ ఇస్ ఫర్ MLOC. ఇఫ్ ఎట్ ఆల్ ఇది ఖాళీ లేదనుకోండి, లెట్స్ ఇక్కడ 2 ఉంది, ఇక్కడ కంటిన్యూస్ 5 బ్లాక్స్ ఖాళీ ఉన్నాయా? నో. సో MLOC ఏం చేస్తుంది? రిటర్న్స్ నల్. అక్కడ if you observe there are more continuous empty blocks, empty single blocks, memory allocate చేయదు. But whereas CLOC, what CLOC does, let's say ఇక్కడ 5 ఉంది, ఇక్కడ 10 ఉంది, ఇక్కడ 25 ఉంది అనుకోండి, ఇక్కడ 3 ఉంది అనుకోండి. What CLOC does, ఇదేమో MLOC ఏమో కంటిన్యూస్ 5 బ్లాక్స్ ఇస్తుంది. మై CLOC ఇక్కడ ఒక 3 బ్లాక్స్, ఇక్కడ ఒక 2 బ్లాక్స్. సో వేర్ ఎవర్ ఇట్ ఇస్ ఫ్రీ, అక్కడక్కడ బ్లాక్స్ తీసుకొని ఇస్తుంది. Understood the difference between MLOC and CLOC? Everyone, ఇప్పుడు చెప్పండి, MLOC బెటరా, CLOC బెటరా? Good, yeah. CLOC is flexible. Very good. But the thing is, MLOC is more advantageous. ఎందుకని? If you observe, CLOC ఉందనుకోండి, ఇక్కడ ఒక అడ్రస్ ఉంటుంది, 100, 104, 108, 112, 116, 120 and all. So 108 వరకు యాక్సెస్ ఈజీగా ఉంది. 160 కి మళ్ళీ అడ్రస్ స్టోర్ చేసుకోవాలి. లింక్ లిస్ట్ కాన్సెప్ట్ గుర్తుందా? యూ హావ్ టు స్టోర్ ద అడ్రస్ అండ్ ద డేటా. So ఇక్కడ there is a confusion and there is more time taking process. You have to store, you have to go to a new location, get the address, go to the new address and more difficulty. But MLOC ఏంటి? Continuous allocation కదా. So we have seen pointer arithmetic, ఇది పని చేస్తుంది. So efficient, time efficient ఏంటి? MLOC. Space efficient ఏంటి? CLOC. Are we clear with this? Are we clear with this everyone? ఇప్పుడు చెప్పండి, టైమ్ ఎఫిషియెంట్ MLOC, స్పేస్ ఎఫిషియెంట్ CLOC, బట్ విచ్ వన్ షుడ్ ఐ ప్రిఫర్? MLOC ప్రిఫర్ చేస్తాం. వై డు వి ప్రిఫర్ MLOC? వై డు వి ప్రిఫర్ MLOC? ఎందుకంటే ఇఫ్ మీ ల్యాప్టాప్ లో స్పేస్ అయిపోయింది అనుకోండి, ఇంకో హార్డ్ డిస్క్ వేసుకుంటారు, సరిపోతుంది. ఒకవేళ టైం లేదనుకోండి, యువర్ రైట్ ఎగ్జామ్, టైం తక్కువ ఉంది, సో టైం ఎక్స్టెండ్ చేయగలుగుతారా? యూ కాంట్. స్పేస్ ఎక్స్టెండ్ చేయగలుగుతారా? యూ క్యాన్. స్పేస్ ని ఇంకొంచెం ఎఫిషియెంట్ చేయొచ్చు, టైం ఎఫిషియెంట్ చేయొచ్చా? చేయలేము, ఫిక్స్డ్ టైం. ఓకే, సో దట్స్ ద రీజన్ వి ఆల్వేస్ ప్రిఫర్ MLOC ఓవర్ CLOC. Is this clear? Chalo. So this is about a few things, and we also have realoc and free. Adi manam chuddam, next class lo we'll continue. And one more thing, we're almost done with the charge, so we'll wind up session here itself today. Okay, mana concept vachi pointers e, but I want to teach you little more than pointers, అందుకే ఇవి చెప్పాను నేను. So this is not what we had in the curriculum we discussed earlier, but still I want you to know these things. That's why I've taught you. And I'll make an assignment on pointers. Okay, once we get a power back. So once my technical issue is solved, I'll make the assignment. Please practice that. And till here, how much you have practiced? Okay, tomorrow there will be a test. Sunday will be a little grand test. Okay, so revise all the topics. There will be a test tomorrow. The test will be active for only 1 hour, and you have to write the codes there. Remember that. They are little difficult codes, not like the usual ones. Be prepared for that. Okay. And any doubts you have, you can use the group we have, or if you are little uncomfortable, you can text me as well. I am there in the group. Okay. So thank you all. Please finish all the assignments. I will share a link as well. You have to post the assignment as well. Remember that. Okay. Thank you all. Have a great day. And if you're good enough, please finish programs on DM as well. Same array programs using DM. Thank you guys.